Just yell it out. What is the main difference between expression and an equation? Equal sign. So which one has the equal sign? The equation. The equation has the equal sign. The expression does not. So if I say simplify this expression, then you have no equal sign. Why is it not writing? So simplify an expression, there's no equal sign. If I say solve an equation, it must have an equal sign. And so whenever you have an expression, the whole goal of that is to reduce it to its simplest form. So reduce to basic form. So for example, if I had 3x plus 2, parenthesis, x minus 5 minus 8. And I wanted you to simplify that, then what I would be doing is I would distribute the 2, combine like terms, and that would get me to its simplest form. So if I distribute the 2, it becomes 2x minus 10 minus 8. And then I want to combine my like terms, so the x's would go together and then the numbers would go together. So that would leave me with 5x minus 18. So just remember, the goal of an expression is you want to reduce it to its most basic form. For solving an equation, it's not always going to be an x. So we will start digging into equations that are not necessarily just x's. That's really what you're used to. And most things will have an x, but you could see other variables as well. And when I say variables, I mean letters, like a, b, c, x, y. That's what I mean when I say variable. So what you want to do is isolate. My Apple Pencil is acting up. I have about 8 Apple products going on right now. Got too much. I think it might be low on battery. Okay, so you want to isolate a variable, and by variable I mean letter, to find all possible solutions. And I say that because we're going to get into quadratic equations, which means it has 2 solutions, or cubic, which has 3 solutions. So it's not always going to be one solution. So if I switched it up and I now took the expression that was in the previous example, and instead of minus 8, I put equals 8. So I just switched it to be equals 8. I would still want to distribute the 2. But then how would this process look different? What would I need to do from here? Add 10. Perfect. And then what happens to the 3x and the 2x? Combine those to be 5x. So now 5x equals 18. And then how do I get that x by itself? Divided by 5. And off the top of my head, I could not tell you what 18 over 5 is. I know it's like 3 point something. Probably, I think it's 3.6. I don't expect you to know that, and I also don't expect you to put it in decimal form. In fact, there's hardly ever a day where I'm ever going to say, I want you to put it in decimal form. The only time I would ever want you to keep it as a decimal would be if we're using our calculators. But we don't use our calculators very often in this class. I hate to disappoint you, but we just don't. And so I would want you to leave this as 18 over 5. And that would be the perfect answer. And that I don't want you to change it to like 3 3/5. Don't make it a mixed fraction. Leave it as improper, and you just have to be okay with it if it bothers you. This is how I want it. If you could reduce it in some way, then I would want you to I would want you to reduce the fraction. But if you can't, this is the simplest that it's going to be. Leave it as is. So maybe make yourself a little note. Mrs. McKinley likes improper fractions. It's like one of my favorite things. Yeah. Okay. So here are some phrases that can be written, or taking the variables and writing an equation for them. So basically taking a sentence phrase and creating an equation from that. So the first phrase is the number of days in W weeks. So whichever variable is written first, that's going to be the variable that you're solving for. Like it would be n equals. So if n shows up first, it's n equals. And so like for number 2, it would be p equals. It's just whichever one comes first. From there, the second variable that I have is w. But we all know that number of days doesn't equal number of weeks. So what number could I put in front that would represent how many days consider in a week? Yes? 7. You can even verify it just to make sure. So if I put in 1 for W, so 7 times 1, okay, I have 7 days in a week, 14, 21, etc. So if you're like, does this equation actually make sense? You can actually verify it by putting in numbers. Sometimes things like this, I think it overcomplicates it. Okay, number 2, the product P, so P equals 2 consecutive integers, the first integer being n. So when I use the phrase consecutive, somebody give me an example of 2 consecutive numbers. Do what? Like 3 and 4. Why does that make them consecutive? They're back to back. So 3 and 4 are consecutive. 4 and 5. 5 and 6. 6 and 7. So, yes?
Why did you put the 7 in front of the
Instead of like after it?
No, wouldn't it go for the number of days?
Like in front of this? Like in front of the n? Well, if I put it in front of the n, then that would mean 7 times the number of days in a week equals how many weeks that is.
Okay.
So if I said there's 7 days in 1 week, that should technically equal 1 week. So there are more days in a week than weeks in a day, if that makes sense. It's kind of backwards thinking, but the number is going to go in front of the weeks to equal the number of days. That's a good question. So in order to make something consecutive, that means they need to be back to back. And the difference between 3 and 4 is how many? Like 4 minus 3 is 1. The difference between 4 and 5 is 1. Difference between 5 and 6 is 1. So if I know that the first integer is n, and it tells me product, I'm going to underline that. What does product mean? Multiply. So I'm multiplying n times the consecutive number. How could I represent the consecutive number in terms of n, meaning like it has n? Yeah, I'm okay. N plus 1. Perfect. You guys are so smart. So for instance, if I chose, like Dalton said, 3 and 4. So if I chose n to be 3, then that would mean n plus 1 would have to be 4, which would get me 12. If I put 4 in for n, then in parentheses would be 5. So just, you can always go back and check your answer and see if it makes sense. Okay, number 3, it's the sum s. So since that's the first variable that's written, what does that indicate about the equation? It's addition. And then what goes on the left side of the equal sign? S. S equals. And then you said sum means addition. Okay. And then I have 3 consecutive odd integers. So, okay, I've got 3 of them. They are consecutive, but they're also odd. So what's an example of 2 consecutive odd numbers?
7 and 9.
Like 7 and 9. So instead of 7 and 8, it has to be 7 and 9 because they're both odd. And so 3 consecutive integers could be 7, 9, and then 11, right? And so if the first one is n, and then you said that, or you guys told me that it's sum, so I would have a plus sign in between. How could I get to that next consecutive odd? What do you think?
Would you use a parentheses n minus 2?
Would it be n minus 2 or n plus 2?
Oh.
Could it be either? It could be either. So you could do n minus 2 or n plus 2, either one. I'm going to stick with plus. You guys can put minus if you want. So if n was 7, and I did n minus 2, that would make it what number? 5. Are those still consecutive? 5 and 7? Yeah. Yeah, Shirley?
Did I say
The first integer? The first integer just, it doesn't necessarily mean that it's the smallest integer, though. It just says the first. So it could be the largest, it could be the smallest. And then what would the, if I'm doing plus, then what would the third integer be? N plus 4, good. If you're doing minuses, you could do n minus 4. So Shirley's question was, doesn't first, like, n is the first one. And so why does that mean, like, doesn't that indicate that that is the smallest integer? And so the answer is no. It could be the largest one. It could have been the smallest one. Either one. Okay, the very last one is the distance d. So that's my first variable. What does that tell me about the equation? Left side is d equals. A car travels in t hours at a speed of r miles per hour. So this is kind of a common equation because I think you probably have seen it in your science classes. So d equals, does anyone remember? TR or RT. Distance equals rate times time. But if I did not know that, if I didn't remember from science class, what about this sentence tells me that they're multiplied together? So a car travels t hours at a speed of r miles per hour. So if you just think about it, and you don't get caught up in every single word too much, but if you just think about it logically, if I'm driving a car and I have speed and time, it makes sense to multiply those together to get your total distance. So I'm going to take the speed that I'm traveling 60 miles an hour for an hour, so I drove 60 miles. Or if I were for 2 hours, I were 120 miles. So if you think about it practically and you plug numbers in, try testing them in your equation and seeing if it works out. Does anybody have questions about 1 through 4 before we move on? Okay, let's move on. I wouldn't say that these problems are very prominent in the grand scheme of this chapter, just something fun. Okay, number 5, when I say the word evaluate, what I'm meaning is I want you to substitute the values that are given into my expression. So it gives me b equals 6 and then g equals 2. And so everywhere that I see a b in my problem, I'm going to substitute that for 6. Everywhere that I see a g, I'm going to substitute it for 2. Now, the biggest thing, I'm going to say this before you guys start because I already see people starting it. Anytime you're substituting, put that number in parentheses. I promise you it makes a difference, and I'm going to show you why here in a second. I don't think it shows up on this one, but on another example it shows up. So I'm going to write it like parenthesis 6 squared parenthesis 2 minus 2 parenthesis 6 parenthesis 2 plus parenthesis 2 squared. And it doesn't make a difference for this problem because everything's positive, but whenever we get to a negative example, it is a huge difference. So when I evaluate this, 6 squared is 36 times 2, 72, minus 4 times 6, 24, plus 2 squared, which is 4. So you end up with 52. Is that what you guys got? Yes? Good, I did it right. Okay, we've already done one kind of like 6, so I want you guys to try this one on your own. And I'm going to freeze the screen, and then I want you guys to check your answer. So try this one on your own. And if you do, then you can pull that out. So negative 2x minus 12 is not technically wrong. It wouldn't be counted completely wrong. I might just take off like minus 1 point for the final step, which would be taking out the common factor. They both have a negative 2 in common. One big thing, things that I see as I'm grading these types of questions is whenever you're distributing this negative 3, some people want to put like plus 3x right here. So when you have a number in front of the parentheses, the sign is also with that. So it's like taking negative 3 and multiplying it by, what is that? A 4. So negative 3 times 4, and then negative 3 times x squared. So that's how I got the minus 3x squared. So now I want you guys to try number 7. So it's just now solving for x. So does anybody have questions about number 7? Okay. Okay. For B, this is where I'm talking about order of operations, how it matters. So let's refresh our memory what PEMDAS stands for. P is for good. E is for and then multiply and divide. Oops. And they can happen at the same time, so that's why I'm grouping those together. And then A and S, add and subtract. And those can also happen together. You read those from left to right. So if dividing comes first, left to right, then you would divide first versus multiply. Okay, so before we start these, one thing that is one of the biggest mistakes I see in Algebra 2 that we're going to clear up, and nobody's going to make this mistake this year, like not even one person, is if I had negative 2 squared versus negative 2 squared. If it were in parentheses, do you think it would be positive or negative 4? I'm hearing both, positive and negative. It is going to be, in fact, positive. Because what it's doing, the long way or the proof, I know you guys love proofs, right? It's taking negative 2 times negative 2 and multiplying those together. Negative times a negative becomes a positive. So if it's in parentheses, positive. Think about it that way. Parentheses, positive. If it were not in parentheses, then it's going to be negative. So you're probably thinking, well, why? technically what's going on behind the scenes of no parentheses is it's using PEMDAS, which order of operations is I'm going to do the exponent first, because what this really reads is -1 times 2 squared. That's technically what that is. It's like a -1 times 2 squared. Negative out in front. Then before multiplication is exponent, so I do the exponent first, which would be -1 times +4, which would become -4. So if you want to think about it the short way, parentheses equals positive, no parentheses is negative. You can think about it that way. Or think about it the long proof way. So with that knowledge, I want you to try numbers 1 and 2 without a calculator. I don't think you have a calculator with you, but I want you to try numbers 1 and 2, and then we're going to compare our answers. It's not in parentheses, so it stayed -16. And then the -4 that was in parentheses, that went to a +16. So the negative and the positive, those canceled each other out, and then I was left with -10. Number 2 should have gotten -18. So I guess technically did this a little bit out of order. I should have done the 4 first and then started multiplying across, because that's exponents first, but I did not. So how I got to the -18, I think the trickiest part of this problem is this minus sign that's in the middle. And sometimes when I see that, I like to go ahead and write -1, parenthesis, -3, parenthesis 4. I'm going to go ahead and do that. And I'm not cheating. I'm not doing anything wrong, because there's an imaginary 1 there. That's what it represents when there's no number. And so I picture, okay, I'm going to take that -1 and it's going to get multiplied by the -3. And then that's going to get multiplied by the 4. So if I'm multiplying across, I have -30. -1 times -3 gives me a +3. So +3 times 4. And then from there, this becomes 12, which gives me a -18. Does anybody have questions about those? Okay, this is going to be our last page, and then we'll stop for the day, and we'll go outside for a little bit while I sanitize. So the last page is just some fraction recollection. Do we all love fractions in here? Yes? Y'all are shaking your head the wrong way. Yes. We love fractions. Fractions are our friends. You're going to love fractions after this class, I promise. They're not as scary as they seem. So if I were to go about simplifying this, let's just brainstorm some ideas. Like, what are some things that I could do to combine all of these? Least common denominator. Could I...
Brackets before the parentheses.
Brackets before the parentheses. In my opinion, I think the best thing to do is to get them all same denominator and then work from there. So I'm going to circle all of my denominators. And what is the number that they all have in common? What could they all have a denominator of? 36. So I'm going to make these little 36s. Here, 4 of them. Now, this 2 over 9, I had to multiply 9 by 4 to get 36. So then what would that make the numerator?
8.
-8. And does it matter if I put the negative on the numerator or out in front? Does that make it different? No. What if I put it on the bottom? Would that make it different? It would not make it different. I would never write it that way, but it would not make it different. So if it were negative on the bottom, that's the same as negative on the top, which is same as negative out front. The only time that it would be different is if I had a negative on top and bottom. And then that would make the entire fraction what? Positive. So it doesn't matter where you write it, top, bottom, out front. It all means the same thing. Minus, what would the next fraction become? Negative 9 over 36. Perfect. Minus, bracket. What about the 5 over 18?
Negative 10.
Negative 10 minus parenthesis negative what? 18. Good. Where's this one? Okay, so from here, I'm going to look at the parentheses first, and the brackets, of course, because that's what comes first in PIMDAS. So my first set of parentheses, I'm going to combine those. And how do I combine fractions? If I'm not multiplying, if I'm adding or subtracting, what do I do with the numerators?
Then you just add the numerators.
Right. So I found my common denominator. Now I just add the numerators. And so my numerators are negative 8 and negative 9. And those combine to be what? Negative 17 over 36. Then I have this minus bracket. Let's try to work in the bracket now. So the first thing I see is this minus a negative. What can I do with that?
Make it a positive. Make it positive.
I can make it positive. So I'm just going to put a big old plus there. Minus a negative is the same as plus. And so based on what I did earlier with the parentheses, yeah, and I have this understood one. I'm going to do that in a second. So I have in my bracket now, I have negative 10 plus 18. What does that combine to be? Positive 8 over 36. And I don't need that bracket that big. Can I drop the brackets now since I only have one fraction in there? Yes. And my last step would be combining these two numerators, which would be what? Negative 25 over 36. Do I leave it be? Can I reduce it at all? No, I can't. I cannot. Okay. Number 4. Has anybody ever seen a fraction over a fraction before? It's kind of crazy, right? So in that case, there's a couple things you can do. If you have a fraction over a fraction, that means you can take the denominator and flip it and multiply across. Or you can multiply every single part of the fraction to get rid of the denominators. So I'm going to show you the first way because I think that's probably the way that we're used to, or it's a little bit easier. But if I were to represent these numbers as fractions, a whole number is just that number over what? 1. So I'm going to write this as 4 over 1, 4 over 1. So when you have a fraction over a fraction, you take the denominator and you flip it and you multiply. So I'm going to take 4 over 1 and I'm going to multiply it by what? 5 over 4. Good. And I'm going to do the same thing with my second one. Whoops. And so what would that get multiplied by? 1 over 4. Now when you're multiplying fractions, that's different than adding or subtracting them. Because what do you do when you multiply fractions? You just what? Multiply across, right? So the numerators get multiplied and the denominators get multiplied. So that would make this first fraction what?
20 over
20 over 4.
which simplifies to 5.
And then what would that make the second fraction? 4 over 20. Now I could go ahead and reduce that to be 5 on the left. But to combine these fractions, what do I need to do anyway?
Common denominator.
A common denominator. What would the common denominator be? 20. So how do I change this guy to be 20?
Multiply the numerator
By 5. So it'd be 100 over 20 minus 4 over 20, which would give me 96 over 20. Wait, why did I put that over 200? Sorry, guys. Does that reduce? 24 over 5. I think also something you could have done in the beginning is reduce this to be 1 over 5 and this to be 5. And then the common denominator would have been 5. And so 25 minus 1. If you wanted to do it that way, like simplified first. But okay, last one. And then we'll go outside. Number 5. So I do have a fraction over a fraction, but I have this multiply or this addition in the middle.
Do you find that LCD first of the fraction on top and the fraction on bottom?
Perfect.
You add that and then you solve.
Yeah, so Jaylee said that I could, like, I'm going to treat the top and the bottom individually first, and then I can flip and multiply after that. But I can't flip and multiply yet because I have these additions. And so what I want to do, like, let's just look at the top. The common denominator for the top would be what? Like, I'm not even concerned with the bottom yet. 10. So that would be 4 over 10 plus 5 over 10, which gives me 9 over 10. Perfect. Now I am concerned with the bottom, and I'm only looking at the bottom, not the top. So if I ignore the top now, and I find a common denominator for the bottom, what would that be? 30. So 3 over 30 plus 6 over 30, which gives me 9 over 30. And now we're kind of at the point where we were for number 4 with a fraction over a fraction. How do I treat that? What do I do? Yes?
You would do 9 over 10 times 30 over 9.
Perfect. 9 over 10 times 30 over 9. Now, before I go and multiply everything out and figure out what 9 times 30 is, because I don't really want to do that in my head, and it makes it longer, I can actually leave it like this. So imagine all of these were in parentheses, and I could actually cancel right here without multiplying everything out, because everything's multiplied by each other. So what can I go ahead and cancel from top and bottom right now? The 9s. 9s can go away because I have a 9 on top and a 9 on bottom. It doesn't work for side by side, but it does work for numerator denominator. So then I'm left with 30 and 10, and that can reduce to be what and what?
3 and 1.
3 and 1. So my final answer would just be, is on your homework, I haven't looked at the homework yet,